Hey guys, it's John here, and I'll test prep with a GMAT problem of the day. This one's number 6. We're continuing our exponents and roots series, but this time we're gonna do a DS inequality, which is actually kind of its own special sort of problem in a way. So is A negative? And we've got some tricky stuff going on here. A cubed times 1 minus a squared and a squared minus 1. So first, I think what we're going to do is let's talk about statement number 1. I think statement number 2 is a little bit easier to deal with, but I just want to go as straightforwardly as possible. So in order for a cubed times 1 minus a squared to be negative, one of these guys is going to have to be positive and one's going to have to be negative. So in other words, like for instance, a cubed would be, let's see, positive when 1 minus a squared is negative, or vice versa, right? So let's see, let's put this on a number line. I always like number lines when it comes to inequalities. And I think I have a nifty ruler function here so that I can draw a straight line. Look at that. So let's see, there's 0 degrees. And I need a little more room. And let's see, so I'll just go there. Perfect. That was pretty awesome, right? Functionality. Okay, so here's our number line. And when it comes to exponents and number lines, it's important to pay attention to the critical strip where exponents display some pathological behavior. So whenever I'm dealing with exponents and an inequality, I like to put this number line down with -1, 0, and 1. And let's examine, we'll say that a cubed is on the top of the number line and 1 minus a squared, 1 minus a squared is on the bottom of the number line. So let's figure out where these things are going to be positive or negative. And so I think, well, a cubed is going to be negative on both parts of the negative side of the number line, right? You cube a negative number, you get a negative. And of course, positive over here. 1 minus a squared is a little bit more difficult. So, like, if we were to plug in, let's test some numbers. A equals -2 for this part of the number line. So that would be 1 minus 4, so that would be negative, right? And then here we can try a equals, we'll say -1/2. So that's going to be 1 minus 1/4, right? Which is 3/4, right? So it'll be positive here, right? Okay, that's cool. And then here we can try a equals 1/2 and we'll get positive again, right? And then for this part, we get a equals 2 and we get a negative, right? And we want the product to be negative. So we're actually, that happens here, right? Negative times positive, and here. So, and let's just throw in some open circles here. Oops, still highlighting. I have a real problem with that. I just can't turn off the highlighter. Anyway, so open circle, and then open circle, right? And the question is A negative? Well, clearly, according to clue number 1, A can be negative or positive, right? So it's either between -1 and 0 or greater than 1. So A and D are out. Now, number 2, we could go with the number line as well, and we will actually graph it, but I think I might just go ahead and solve this analytically. So if I add 1 to both sides, I get a squared is less than 1, right? And then square rooting both sides. So when you square root to solve a quadratic inequality, it's important to realize that you get absolute value of a on this side. So that's a really important rule. Square root of x squared is absolute value of x. And mainly you have to know this for these inequalities. And I will explain why over here. So if I were to just square root like x squared equals 4, then we just do plus or minus 4, right? Plus or minus 2. We square root both sides, and we don't even really think about it. But if I were to say, like, a is less than plus or minus 1, that doesn't really make sense, right? I mean, is that an or inequality, an and inequality? Which one is it actually less than? I'm not sure. But this, absolute value of a is less than 1, well, that does make sense, and we can graph that. So I get out the ruler again, drag it down, and there's my line. Get rid of the ruler, throw down some arrows, critical strip again. Okay, and so absolute value of a is less than 1. That means that a is within 1 unit of 0 on the number line. So that means we're here, right? And between these two guys, oops, highlighter when I want it, there we go. So that's a for number 2. And clearly, you know, you've got both possibilities, like here a is less than 0 and here a is greater than 0. So we don't know if a is negative. So b is out. And yeah, okay. Any questions so far? I hope not. Obviously you can't answer me. I don't know why I just threw that in there. So now we got to consider 1 and 2. And one of the nice things about doing this with the number line is that we can look at where the number lines overlap. And where they overlap is right here between -1 and 0. And the overlap actually doesn't include 0. That's important to note, and it doesn't include -1. So in that case, we know that a is greater than -1 and less than 0, which means a is negative. So 1 and 2 together are sufficient. And the answer is C. So pretty complicated. What are the takeaways here? Number lines are helpful when it comes to DS inequalities. Testing numbers can be useful, but you got to be kind of focused in your testing. And always you want to consider numbers in this critical strip around 0, where you have fractions and exponents tend to exhibit some weird behavior. Also, square root of x squared is absolute value of x, and this is the absolute best way to solve quadratic inequalities. And also this negative positive sort of breakdown of the number line I think is pretty useful as well. So don't forget to subscribe, leave me some comments and some likes or dislikes, I guess. And keep coming back for more. Thanks.